Hi, this video is about the age of misinformation. With the advent of the internet and the World Wide Web, much of human understanding is now available to you in a little pocket-sized device, meaning your phone, which is incredible. You can find out about almost anything that you're interested in just by doing a web search. The problem with this is that all of this information isn't all accurate, and that was why I've titled this video The Age of Misinformation. In this video, we're going to talk about classifying information, the different levels of information that are available on the internet, how to find good and truthful information, breaking down arguments that people use to convince you about various types of information, and then analyzing statistics and graphs. When you get to the end of these series of videos, hopefully you'll be able to easily break down arguments, find good information, and use the internet to your advantage. Today, information is ubiquitous. Because of the internet, because of the global network that connects us all, if you have a smartphone, you have all of humanity's information in your pocket. There's two impacts to this. First of all, because there's this huge amount of information, when the internet first sprang up, there really wasn't a way to search through it and find it. Yes, there were some nice, useful pages, and there were some kind of weak search engines, but it wasn't until Google and Bing and Yahoo and Microsoft came up and developed search engines that it became possible to find as much information as you could possibly ever want on any topic. That's a good thing. Another thing that happened was the loss of the gatekeepers. Before, if you wanted to publish information, you had to convince a publishing house to take your information, put it in a book, and distribute it to people. With the advent of the internet, anybody with an internet connection and even a rudimentary understanding of how to use a computer could broadcast their ideas to the entire world. The loss of the gatekeepers is both good and bad. When you had gatekeepers, they got to decide what information is available. Every human has bias. Because of that, they could prevent information they didn't like from being published or promote information they did like. With the loss of the gatekeepers, now there has been a massive flowering of ideas. All sorts of information is available on any subject, and it can be from people all over the place. The downside of that is many times, or maybe often, people who publish information on the internet for others to read do not have valid and sound opinions. And we'll go into examples of this as we go along. Before you start to use information, sometimes it's useful to make sense out of it. And one of the ways you can do that is classifying it. For our purposes, I'm going to classify information into 4 levels. First of all, there's primary literature, there's secondary literature, there's tertiary literature, and then finally there's popular press. Let's look at what each one of those is. The primary literature is research articles published in peer-reviewed journals. So example I'm showing you here is elevated acetyl-CoA by amino acid recycling fuels, microalgal neutral lipid accumulation and exponential growth phase for biofuel production. Wow, that's a mouthful. So you can see they have very specific titles. Normally for primary literature, an expert in the field writes the article. Secondly, it asks a scientific question. In this case, you're looking at how increasing acetyl-CoA levels because amino acids are recycled helps increase lipid accumulation. And this is basically involved in research on biofuel production. The paper will provide methods and present data to test the question. If you look through this paper, there will be a methods section that describes in great detail how the experiments have been done. The detail is good enough that someone who knew the field, or even probably your general scientist, would be able to accumulate the materials and do the methods such that they could repeat the experiments. As you can see from the title, these research papers are very specific. They'll answer a very specific question. You might wonder, what is peer review? Peer review is when other experts in the same field analyze the article and judge it suitable for publication. Mechanistically, this works by you write the article, you submit it to the journal, the editor at the journal looks at it, and she decides, first of all, probably if it's in the scope of the journal. Then if it is, she will send it out to 2 researchers or more in the field to get their opinions on what they think of the article. And these 2 reviewers will look at this article very carefully, look at the data, look at the methods, look at the conclusions that are drawn, and if they think it is valid, they will recommend it for publication. If they don't think it's valid and sound, they will reject it. Since the article goes through such an extensive review process, it's not surprising that the information contained in the primary literature tends to frequently be of high quality. It also frequently tends to be not very accessible to the general public. But if you work hard and you're interested in a subject, you can read the primary literature and get stuff out of it. That is not to say that the primary literature is always right. There are times when articles are published that they then have to be retracted, either because a mistake was made, intentionally or unintentionally. And that gets into scientific fraud, and honestly, that's extremely rare. So you can pretty much trust the primary literature, but you should still be skeptical of it. The second level of information is secondary literature. In this case, experts will summarize and review a field of study. There's no new data, but there will be numerous citations to the primary literature. So here is an article in Rejuvenation Research, and it says exercise attenuates the major hallmarks of aging. And this article goes through and looks at all the different research that's been done in this field. These articles are almost always peer-reviewed, and because of that, they're highly trustworthy. So a common example is review articles. How do you tell the difference between primary and secondary literature? Well, one quick way is to look for a materials and methods section. If there isn't a materials and methods section, it's probably not primary literature. It's more than likely secondary literature. Tertiary literature will also often be written by experts. Now, this is a further distillation of information. It will have a broader topic than a review article like in secondary literature, and it will have a wider audience, such as scientists, students, and even non-scientists, depending. The example here I'm using is Bergey's Manual of Determinative Bacteriology, which is a manual that lists thousands of microorganisms and how to identify them. There will be fewer citations. There's still a lot of citations in Bergey's Manual of Determinative Bacteriology, but they're not as dense as in a primary or secondary literature article. And examples include textbooks, manuals, dictionaries, and Wikipedia. Yes, Wikipedia. Often the articles that you find on Wikipedia are written by experts. They also will be heavily adorned with citations, so it's quite easy to look up the information they're writing about and see if it's correct or not. So I think Wikipedia does qualify as tertiary literature. Finally, there is the popular press. And this is rarely written by experts. The target audience is the public, so basically as wide as possible. They may reference an article of interest, but they may not. It's not peer-reviewed. Sometimes there's an editorial process, especially if it's written by a reputable organization like a newspaper or a magazine, but they're not experts in the field. And the popular press is the least reliable. But you can still find good information, especially if you're first learning about a topic that can then lead you to more authoritative information in the primary, secondary, and tertiary literature. But you can also find a lot of bad information. The example I hear here is from a magazine, and it's Why You Must Eat Chocolate Every Day, where it's talking about how those who ate chocolate lost more weight than those who didn't. And it's actually based on a sting study authored by Johannes Bohannon, who was trying to demonstrate that there are these shady journals out there that will publish anything. And he wrote this bogus article that he knew was incorrect, and just wanted to see if he could get published. And then the popular press picked it up and went crazy with it. He had to spend a significant amount of time trying to then undo this, but it was quite interesting and humorous.
The story of the sham chocolate research article leads into the concept of predatory journals. And these are journals that will happily publish your work, but have no real scientists behind them and have no real editorial process or peer review. The sham peer review does not have any qualified editors. They have no qualified reviewers. And in fact, when you submit an article, they just immediately turn around and a couple weeks later or a few days later will tell you that the article's been accepted and they'll publish it for you. You may wonder, why would anyone want to do this? And it's because of money. Traditionally, authors help finance journals by paying page charges, and to publish an article in a journal can cost thousands of dollars. So the webmaster that is running one of these sites ends up having the potential to make a significant amount of money if they can get enough scientists to publish articles in their journals. The good news is scientists are fighting back. They have developed a list of predatory journals, and when it becomes clear that these new journals that pop up are not real journals and don't have a real editorial process, you get put on this list. You can find it here at this URL. I encourage you, if you ever run across a journal that you're not familiar with, that you go to the list of predatory journals and make sure that it's not on that list.
Thinking about predatory journals brings up the idea of, well, how do you find reliable information? So there's several ways, and I'm going to go from these are all things I recommend, but probably from least reliable to most reliable. One thing you can do is you can go and look at Wikipedia. It actually has a number of really good articles on it. In fact, much of it is quite good. So let's say we're looking at, probiotics. All right, so you click on probiotics, and then you can come up with a large article listing all the different types of concepts of probiotics and what has been used, etc., etc. And you'll see that there are a huge number of references, and this is a good sign that this is a good article. And if you look at the references, many of them are from the primary literature and the secondary literature. So they're research articles and review articles, and that's a good sign that this is a good place to learn about information. Another place that you can go, and this is one that lots of people use, is using Google or Bing, Yahoo, Ask, or AOL Search. And these are all reasonable, good search engines. The one issue with using these is that any information that's brought to you is indexed by our other people linking to it and using it. And there can be a number of information that's just not that good. So you have to be careful about what you look at. Another thing with search engines is they listen or watch everything you're searching for, and then will use that information to then show you ads. That's how these businesses make their money. Now, one search engine that doesn't do this is DuckDuckGo. So if you go to DuckDuckGo and you type in probiotics, you can get all sorts of information about probiotics, and they promise not to track you, just if you're interested. Now, we go to more specific academic sites, and these are sites that are dedicated to scholarly articles. One of the most popular is PubMed. PubMed has up more than 27 million and actually now 28 million citations for biomedical literature. So you can search for all sorts of stuff in here. And again, I'll search for probiotics, and it will list literally thousands of primary articles and review articles on probiotics. And it will talk about all sorts of stuff. And you can see this first probiotics one. Probiotics are a good choice in remission of inflammatory bowel disease, a meta-analysis and systemic review. And that's a review article that talks about the use of probiotics to treat inflammatory bowel disease, etc., etc. So there's thousands of different articles that you can see through here. PubMed Central is a kind of a subset, but it has other materials in it of PubMed, and these are all free open access articles. One of the downsides of PubMed is that some of the articles it links to are not open access. In fact, you have to pay subscriptions to actually see them. If you're at a university or other academic institution, often the libraries there pay for the subscriptions and you can actually get to them. But in many cases, if you're just in the general public, you can't get to these articles. Beyond PubMed and PubMed Central, Google and Microsoft have gotten into this space and have created Google Scholar and Microsoft Academic that kind of do the same things that PubMed does. One of the advantages is Google Scholar and Microsoft Academic will index all scholarly journals, not just biomedical sciences. Finally, there's also a large collection of academic journals that will group together and have large collections of their own. And these are all open access, which is actually pretty neat, because what that means is that they are free for the public, and anyone who's interested in the field can go read these articles. And they're exceedingly good quality. These are peer-reviewed journals. So the directory of open access journals, PLOS One and Biomed Central.
Right now I'll click on PLOS One.
And you can again type in probiotics and do a search, and you'll get all sorts of articles, again, on probiotics. PLOS One is an interesting case because it's the Public Library of Science and was specifically started to give a place for open access to research on various fields. And you can see all sorts of articles on probiotics here. So that's how to find information that you're interested in.